Hello everybody and welcome to the first episode of our JavaScript Basics series. This is a series that will be covering the basics of JavaScript such as JavaScript variables, data types, operators, control structures, functions, arrays, and objects. So if you're a complete beginner at JavaScript, this is the course for you. And even if you know some of the basics of JavaScript, I'm sure this course will prove helpful to you. And if you complete this course and want a certificate to show for your hard work, make sure to head over to codin.com or check the course link in the description. Well, let's get started with our video. Alright, first things first, what is JavaScript? JavaScript, or JS in short, is a programming language that is used to make websites interactive. Think about clicking buttons or showing pop-ups. Even loading the content without refreshing the page. All of that is JavaScript. It works together with HTML and CSS to bring websites to life. JavaScript is used by companies such as Google, Facebook, and Netflix to make their websites fast and fun to use. And now that we know what JavaScript is, let's set up our environment to start coding. In order to run JavaScript, we need a place to type and test out our code, and there are two simple ways to do this. One of the ways is using our browser console for the super quick execution of our code. Every web browser, may that be Chrome, Firefox, or Edge, has a built-in JavaScript console where you can run JavaScript code instantly, and here's how you can try it out. You can open your web browser, in this case I'm using Google Chrome, and open a new tab. Right-click anywhere on the tab and click on Inspect. Here you can see the Elements page open up, and you can click on console, and here we can type out our JavaScript code. In this case, I'm going to type a simple code that is console.log hello JavaScript. After you're done typing your code, you can hit enter, and as you can see, hello JavaScript is printed on the console. And there you have it, you have written your first JavaScript code. While running our JavaScript code on the browser console itself is a simple method, for bigger projects we use a code editor like VS Code. So let's start by installing VS Code on our PC first. And in order to do that, we have to head over to code.visualstudio.com, and the website should show you a download button according to your system. Click on download, and a set of files should start downloading. And since I've downloaded the setup file already, I'm gonna delete this from my history, and I'm gonna run the setup file. Click on I accept the agreement. Next, this should be the default path. This should be the default path for your VS Code install. And click on next. Next. Create a desktop icon if you like, and click on next and install. It should start installing, and you can wait for the install to be over. After it is done installing, you should be greeted with this window right here. And I have left a tick on Launch Visual Studio Code since I want to run VS Code right now. Click on Finish after you've done installing it to launch VS Code. After opening VS Code, you'll be greeted with its welcome page like this. And before we start creating our files and writing our JavaScript code in them, I want to tell you guys about an extension that will prove helpful to us. For that, we have to head over to the extensions section and then search up Live Server. Click on this first search result by Ritwik D, and you can click on install. It'll be done installing in just a moment. As you can see, it has been installed, and now we can start creating our JavaScript files. For that, you can head over to your desktop and create any folder. In this case, I'm going to name the folder JavaScript. And then you can reopen your Visual Studio Code and then head over to this Explorer page and click on Open Folder. You can head over to Desktop and choose the folder that you just created. In my case, this is JavaScript. And you can select the folder, and it will show you that the folder has been opened. After you open the folder that you just created, you can now start creating files and writing your code in them. Before you start writing your JavaScript code, you can create an HTML file first. In this case, I'm going to name it index.html, and I'm going to create another file that is script.js. You can now write a basic structure for your HTML file, and we can do that by using a shortcut, and which is typing out the exclamation mark and hitting enter. As you can see, it has created a basic structure of our HTML file, and you can change some details here. I'm going to title our HTML file JavaScript, and I'm going to open a script tag above the closing tag of the body, and I'm going to name it script src, and our JavaScript file's name, that is script.js. What this does is it links our JavaScript file to our HTML file, and so that we can open this website and check out the console to see if the JavaScript code that we have written is working. I'm gonna hit save, and now we are ready to write our JavaScript code. Let's type out the code that we tried out on our Chrome console, which is console.log hello JavaScript. After you are done typing out your code, you can hit Ctrl S, which is save, and then open your HTML file through the Go Live button right here. As you can see, we have opened our HTML document, which is titled JavaScript. And what you can do to see if your code has worked or not is you can right click anywhere on the file and click on inspect. What this does is it opens the developer tools of the website, and you can check out your code on the console. And you can see that hello JavaScript has been printed onto the Chrome console. So this is how you can write your JavaScript code and check out if it has worked or not. Okay, so you have written console.log hello JavaScript and printed out hello JavaScript onto your Chrome console. But let's try something new. Suppose you want to alert the user about something through a pop-up message. Well, JavaScript allows you to do that through the alert function. If you type out alert, oh sorry, it's on caps lock. If you type out alert and then a message inside your alert function, suppose, hey, welcome to JavaScript. And click on save through Ctrl S. You can see that your Chrome, your HTML file has been updated, and this is due to the live server extension that we installed just now, which updates your website live. And to check out what changes have occurred, we can open our HTML file, and as you can see, hey, welcome to JavaScript has been alerted to the user, and if we click on OK, our HTML file resumes as it is. And if we click on inspect and go to console, we can see that our previous code is working just fine. And that's how you use the alert function in JavaScript. And that being said, you should be careful while using the alert function and avoid using it too much, since it stops all other code execution and essentially pauses the website until the user clicks on OK. Just to show you how it works, I'm gonna give you a small demonstration. Let me go to the Chrome console by clicking on inspect and go to VS Code to edit our code a little. I'm gonna type console.log. I don't want to be paused, and keep it under our alert function. And if we click on save and go to our web page again, we can see that nothing is being printed on the Chrome console until and unless we click on OK. And after we click on OK, the rest of the JavaScript code is executed. And if you want to see your alert function running when you freshly open the web page, you can go to VS Code once again, click on your HTML file, and then click on port to dispose the server. After the server is offline, you can click on Go Live once again to freshly open the web page. And you can see that when the web page opens, a pop-up is shown with whatever message you put inside the alert function, and that is how the alert function works. And that is why you need to be careful while using the alert function. And that's it for this episode. We learned about what JavaScript is and ran console.log on our browser console, and even wrote some code in VS Code which included the alert function. And in the next episode, we'll be diving into variables and data types, so do stick around for that. And if you found the video helpful, make sure you leave a like, hit that subscribe button, and if you want a certificate, please check out coding.com. Thank you. Hello everyone, and welcome back to our JavaScript beginner course. If you watched episode 1, then you now know what JavaScript is and how to set up your coding environment. And if you missed it, no need to worry, since the link is in the description and you can go check it out. By the end of this series, we'll be building a real-life project together, so make sure to stick around. And if you have any questions, you can drop them in the comments and we'll try to answer them or cover them in the next episode. So let's dive right into variables and data types. So what are variables? Imagine you have a box in which you can store all of your favorite things inside. Well, in JavaScript, variable is similar to that box, as in we can store information inside it that we have to use later. If you want to store your name, age, or even your exam marks in JavaScript, you can use variables. So let's see how to create variables. You can always use VS Code to write and execute your JavaScript code, but for easy functionality, I'm going to be using Codin.com's compiler. You can go to Codin.com, then more, then compiler, and there you can see there are a lot of languages to choose from, and today I'm going to be using JavaScript. And let's remove this right here. And there are 3 ways which in JavaScript to declare variables, and one of the ways is var, which is the old way and it is not generally recommended, and let me show you why. Suppose I use the var keyword to type out a variable that is username, and I set its value to a string, let's say Alex, and if I type out console.log username, that is I use the variable, it outputs to Alex being displayed on the console. But we can use var to redeclare the variable name, that is var username equals to Sam, for instance. And let me type out the same command, that is console.log username, and we can see that the value is updated, but it is updated by redeclaring the variable name, which might cause problems in big projects, so it is not generally recommended. The other way to declare variables in JavaScript is by using let keyword. What this does is it allows updating of the values, but it does not allow redeclaration of the same variable names. So let's see, let age equals to an integer, that is 20, and console.log age. As you can see, 20 is displayed on the console, and let's the way you can update variables through using the let keyword is just writing its name, variable name, and just updating the value as it is, so 45, and let's see console.log age, and it outputs to 45. So this is a good practice since you can update the value but can't redeclare the variable. The third and final way that you can use to declare a variable is using the keyword const, which seemingly stands for constant, which means that once you declare a variable, you cannot update its value further in the code. And let me demonstrate that through an example. So I'm going to delete this code right here and write const birth year equals 2006. And I'm going to use the same console.log function to show you that the declaration of the variable is working. So it outputs the value of the variable in the usual way, but if you try to further update the value of the variable birth year in the code, birth year equals to 2005, you will see that we will run into an error, which is type error assignment to a constant variable, meaning that the variable cannot, which is declared through the keyword constant or const, cannot be further updated. Of course, you can change the value of the variable during the declaration itself. It is updating the value, but you cannot update the value further down the code. So you can see 2005 is being printed, but we run into an error when we try to update the value. So you should use const and let according to your situation. Now that we know what a variable is and how to declare variables using different methods, let us talk about a concept that distinguishes the declaration keywords that we just discussed. The concept is that of the variable scope. So what is a variable scope? The variable scope refers to the accessibility of a variable within different parts of a program. It determines where a variable can be accessed or modified. In JavaScript, the scope of a variable can be either global or block scoped. So let's discuss what they are. First, we have global variables. A global variable is a variable that is declared outside any function or block and can be accessed from anywhere in the script. And it can be modified by any part of the program. The var keyword is used to declare global variables in JavaScript, and it is not generally recommended because it increases the risk of conflicts. Next, we have block scoped variables. The keywords that are let and const were used to declare block scope variables, and these are the variables that can be declared inside a block and can be only accessible within that block, which prevents accidental modifications, and it helps in writing cleaner and safer code as well. So let me demonstrate that with an example. So what I'm going to do is I'm going to open our previous code on the coding compiler, delete it, and I'm going to declare a variable using the var keyword inside the block. A block of code is signified by these curly braces right here. So var username equals to Sam. I'm going to close the block, and I am going to try to access the variable using console.log username, and we can clearly see that this is trying to be, the variable username is trying to be accessed outside the block of code that it is declared in. So if we run it, we can see that the variable is accessed and printed out with the console.log function into the console. Now we're going to use let to declare the same variable and try to access it outside the block. Remember that let is a block scoped variable declaration keyword, so we're going to see what we run into. You can see that username is not defined, which means that it cannot be accessed from the scope it is declared. It cannot be accessed from outside the scope it is declared in. Let us try with a const, and we'll see that we run into the same problem. So username is not defined, and that's the scope of variables. After having an understanding about variable scopes, we can move on to the topic of data types in JavaScript. Every value in JavaScript has a type, which is like a category, and here are the 5 basic data types that you'll be using all the time, which are strings, numbers, boolean, null, and undefined. And I'm going to demonstrate each and every one for you. We can take this very code as an example. In this code, Sam, which is enclosed inside the double quotation marks, is a string. A string is used to store words or sentences or any text, and which can be assigned to a variable. If we change the declaration keyword for this to var, which makes it global scoped variable just for demonstration, we can see that this string will be printed onto the console when using console.log. The same is with numbers. Numbers can be decimals or even integers, and we can use numbers in the same way. Numbers can be used to add or perform different arithmetic operations through the use of operators like the add sign, which we'll be discussing in later episodes. So 19.1 plus 9, it should print whatever the sum is. So we can see that how numbers can be used in JavaScript. Whereas Boolean values can either be true or false, which are useful in conditional statements. So what I'm going to do is I'm going to declare a variable called isStudent, and I'm going to set its value to true, and console.log isStudent, which is going to output to 2. Now Boolean values are not just assigned to a variable, but it can be obtained through an expression as well. So if I were to type out an expression like 19 is less than 20, which is true, it will still output to true. And if I were to change this value of 19 to 21, which is not true, 21 is not less than 20, it will output a false value. So that is Boolean in JavaScript. And sometimes a variable is intentionally empty, and that's where null values come in. So if I declare a variable called isStudent, I'll set its value as null, it's gonna output to null. And a case where you declare a variable as null is when you don't know what the value of the variable will be, but you want to declare a variable to use in the future. So if I use let isStudent equals to null, it will output to null for the while. But if I update its value, isStudent equals to true, and it will be set to true, and we can use this value in the future. So if you want to just create a variable and keep it for a while, you can set its value as null, and it will output to true the moment we update it. So that is it for the null data type that you assign to a variable. And the final data type that we are going to discuss today is the undefined data type, which occurs when you don't assign a variable a value. So if I don't assign this let isStudent any value after declaring it, it will output to undefined and then only true. So in order to avoid undefined showing up on your console or anywhere in the browser, you should always give a value to a variable when declaring it. And that is it for the data types that we will be discussing today. And now it's time for a mini challenge. I'm going to write down a code and you guys can guess what will be the answer or the output, and put your guesses in the comments below. So the code is const username equals null, and updating the value username equals to Sam, and console.log username. So you guys can put your guesses in the comments below, and we'll see you guys in the next episode. In the next episode, we are going to learn about the concept of operators and expressions to make our JavaScript even more powerful. So don't forget to tune in next time. If you like the video, don't forget to drop a like, subscribe, and we'll see you guys in the next one. Hello everyone, and welcome back to our JavaScript Basics series episode 3. If you have been following along, you know that we discussed variables and data types in episode 2. And if you missed this episode, you can go check it out. The link is in the description. By the end of this series, as stated in episode 1, we will be building a real life project together, so make sure you stay till the end. And remember, if you have any questions, you can drop them in the comments and we might cover them in the next episode. Now, today's topic is operators and expressions. These are the building blocks for writing powerful JavaScript programs, so let's dive right in. So first of all, what are operators? Like in many other programming languages, in JavaScript, operators are special symbols that perform an action on one or more values, and they can be of different types. The types that we are going to be discussing today are arithmetic operators, comparison operators, and logical operators. So first up, arithmetic operators. They are used to perform math operations like addition, subtraction, multiplication, and more. And I'm going to be using the compiler to demonstrate how they work. So what I'm going to do is I'm going to declare two variables, that is let a equals to 10 and let b equals to 5, and use the console.log to demonstrate the arithmetic operators being used. So a plus b and console.log a minus b, console.log a. The symbol for multiplication in JavaScript and many other programming languages is asterisk or star. A asterisk b, and console.log a divided by b. So these are the basic arithmetic operators, and it should result to the sum being printed 15. A minus b is 5, a times b is 50, 10 times 5 is 50, and 10 divided by 5 is 2. And along with these arithmetic operators, there are two more arithmetic operators which are unique or special, that is console.log a modulus, which is symbolized by percentage b, and console.log a double asterisk, which symbolizes exponential, that is a to the power of b. So what the modulus symbol does is it gives you the remainder of the division. So 10 divided by 5 leaves 0 as its remainder, so it should output to 0, and 10 to the power 5, it should give you 100,000. So 10 divided by 5 leaves the remainder of 0, and 10 to the power of 5 is 100,000. So these were the arithmetic operators, and we are now going to be looking at comparison operators. Comparison operators compare two values and return either a true or a false value, which are Boolean values, and we made use of comparison operators in the second episode, and these are super useful in decision making. So let's say a equals to 10 and b equals to 5, that is constant, and console.log a is less than b, which is false, so it should output to false, and a is more than b, which is true, so it should output to true. Like this, there are many comparison operators in JavaScript, and I'm going to be demonstrating every one of them. Another comparison operator is the double equals to sign to compare values. So I am going to use the double equals to sign first, and another strictly equals to comparison operator is 3 equal to sign. Since you use 1 equal to sign to assign values to variables, the double equal to sign is used to compare variables, and the triple equals to sign is used to strictly compare the variables. That means it will both output to true at first because both are essentially the same. But if I were to type out here a string 10, the first console.log, that is just the equals to operator, would output to true, but the strictly equals to operator also checks the variable data type, that is, if they are the same data type. In this case, a is an integer or a number, but b is a string, so the first will output to true, but the second will output to false, since it strictly checks the data types as well. And if you want to check if two values are equal or not, you can use the not operator, which is symbolized by the exclamation mark. This checks if a is not equal to b, and this checks if a is strictly not equal to b, and this should output to false, and this should output to true, because 10 is not equal to 10 is false because it is checking only the values and not the data types, but this is checking even if the data types are equal or not. Since they are not equal, it should output to true, so false and true. And these are the comparison operators in JavaScript. Also, a bonus tip for you guys: it is the best practice to always use the strictly equal to and strictly not equal to operators to avoid unexpected errors. And moving on to logical operators, the logical operators are the operators which help us combine multiple conditions, and the three most used logical operators are the AND operator, the OR operator, and the NOT operator. The AND operator in JavaScript is symbolized by these two AND symbols, and this returns a true value only if both the conditions are true. And the second operator is the OR operator, which is symbolized by these symbols, and it returns a true value if at least one condition is true. And as we discussed earlier, the NOT operator reverses a Boolean value. So I'm going to break them down one by one. Let's start with a real life example first. Suppose you want to go on a road trip, and you can only drive the car if you have a license and a car, but you can be a passenger if you have a license or a car. And if you don't have a license, you can't drive. And this is the NOT operator, which is not license, so you can't drive. So let me demonstrate with a bit of code as well. I'm going to create a variable called let has license equals true, and let has car equals false. So let can drive equals has license and has car. Let can or be passenger equals has license or has car. And let's create another variable. Let cannot drive is if the person does not have a license. So the reason I declare these variables using the logical operators are: the person can drive if he has a license and has a car. The person can be a passenger if he has a license or he has a car. So either way, if one is true, he or she can be a passenger. And the person cannot drive if he does not, this is the not operator, does not have a license. So let's see what these variables output to. By using console.log can drive, then console.log be passenger, and then console.log cannot drive. So let's see what these output to. As you can see, the first condition can drive outputs to false, because in this the both condition are not true. So has license is true, but has car is not true, so it outputs to false. Be passenger outputs to true because one of the conditions is true. In this case, has license is true, so it outputs to true. And it outputs to false because not has license means not true is false. So these are the logical operators in JavaScript. Up next, we have the topic of type conversion and coercion in JavaScript. JavaScript is a loosely typed language, which means that it automatically converts values when needed, which is called coercion. And I'm going to show you this through a small example. Up in the compiler, I have prepared a small code to demonstrate and outputted the values. In the first case of console.log, a string 5 plus 3, which is a number, this number is converted into a string, and 53 is outputted through string concatenation, which is joining the string values together to output the joined value. And in the second case, 5 is converted into a number, so 5 minus 3 is outputted to 2. And in the third case, that is console.log string 5 into or times string 2, both values of string are converted into a number and outputted as their product. Second case of type conversion is here, where boolean values are treated as 1, true is treated as 1, and false is treated as 0. So 5 plus 2, that is 1, is 5 plus 2, that is 1, is 6, and 5 plus 0 is still 5. The third case is that of manual conversion. Since, as we saw in the first example, the automatic conversion or coercion is unpredictable, so it is best practice to convert the values manually into the required data types, which I have done in this code in 3.js file, where I have used the number data type declaration and wrapped the data type to be converted in parentheses. And if you can do this similarly with string and boolean values. Boolean values, 0 is treated as false and 1 is treated as true. So we can see the output here. That is, 5 is converted into a number, so 5 plus 3 is 8. Here 5 is converted into a string, so string 5 plus 3 is concatenated and outputted as 53. And boolean values, 0 is converted into false and 1 is converted into true. So this is it for type conversion in JavaScript. And before wrapping up, I have a challenge for you guys to try. So you have to guess what will be the output of this code. Console.log a string value of 10 plus 5 minus 3. Post your answers in the comments below, and we'll see you in the next episode. In the next episode, we'll learn about control structures, that is if-else and switch statements, which help us to make decisions in JavaScript. So if you found this video helpful, leave a like and subscribe, and do drop your questions in the comments. See you guys in the next one. Hey everyone, and welcome back to our JavaScript beginner course. In the last episode, we explored operators and expressions, how to perform calculations, compare values, and use logical operations. If you missed it, you can check out the link in the description. But now, let's dive into something fundamental in programming, that is control structures. These are what allow our code to make decisions and execute different actions based on conditions. So let's get started. What are control structures? Control structures help us to control the flow of our program based on conditions. Imagine you have a self-driving car. It needs to decide when to stop, when to go, or when to turn. And in JavaScript, we make these decisions using if-else statements for simple decision making and switch case statements for when you have multiple choices. So let's start with if-else statements first. So this is the format of the if-else condition in JavaScript. There is a condition inside the parentheses after the if keyword, and then a block of code to be run if the condition is true, which is enclosed inside the curly braces, and then an else keyword, and then a block of code to be run if the condition that is stated above is false. So if this condition is not true, the else block of code will be run. So let me demonstrate this with a small example in the compiler. Let's say I have a variable called let age equals 18 for now. So if the condition is age is more than or equals to 18, console.log you can vote, and else it should print you are not old enough to vote. So how this works is, if the age is greater than or equal to 18, this block of code, that is the console.log you can vote, will run. Else the console.log you are not old enough to vote will run. So let's see what happens here. As expected, it will output to you can vote, and if I change this value to 17, the else block of code will run and it will print you are not old enough to vote. This is the result because the condition that we have stated inside the if block, that is age is more than or equal to 18, is not true, since we have set the value of age to 17 and 17 is not more than or equal to 18. So the else block of code is run and it will output to you are not old enough to vote. And this is the if-else condition in JavaScript. Now, what if we have multiple conditions? That's where else if comes in. In JavaScript, the else if condition has the following format. The if condition and the else condition are essentially the same, but if we want to check for another condition to be true, we add an else if block. That is else if keyword and a condition inside the parentheses and a block of code to be run if this condition is true. And if all of the above mentioned conditions in else if and ifs are false, the else block is executed. So the block of code to be run if all the conditions above are false. And I'm going to give you an example of this as well. So let me delete this and then write let score equals 85. Let's say we have to develop a grading system to print out the grade according to the score. So we have to set up multiple conditions. First of all, if score is more than or equal to 90, it will print out console.log grade is A. Else if the grade, or I guess score, is more than or equal to 80, it will print out console.log grade is B. Similarly, else if score is more than or equal to 70, console.log grade will be C. Sorry, grade C. And let's say anything below 70 is a failing grade. So else console.log you have failed. So let's see what is the output for this code. As expected, 85 is more than or equal to 80, so this condition is true, so its respective code block will be run, that is console.log grade is B, so grade is B is printed. and if we set the score to 95, it should output to grade is A, and if it's anything below 70, for example 50, it should output to you have failed. So this is how you handle multiple conditions in JavaScript through the if, else-if, and else statements. Now let's take a look at the switch case statement. Sometimes we may have many possible cases like the days of the week or menu options, and instead of writing multiple else-if conditions like such, we can use a switch case. So the format for a switch case is as presented. There is an expression inside the parentheses after the switch keyword, and inside the curly braces we have multiple cases that can be executed, multiple cases and their corresponding code to be executed, and if none of the cases match, we have a default case and its code to be executed. Also, you might have noticed the break statement being used after each code block, and this is really important because the break statement stops the execution of the switch statement after a matching case is found, which means if case 1 or value 1 is matching with the expression, this code will be executed, but if the break statement isn't here, the next case statement will also be executed. So in order to prevent that, we should use the break statement, and I'll demonstrate this through an example. So if I type out switch, let's say declaring a variable called day equals Tuesday. So switch and then day case 1, let's say Monday. If it is Monday, let's print out console.log it is Monday, and let's add a break statement, that is break, and another case which is case for if it is Tuesday, case Tuesday console.log it is a Tuesday. A break statement again, we should not forget this, and let's say we have two cases where it should be called a weekend. So Saturday and case Sunday. So you can use the same code block for two codes or two cases. Console.log it is a weekend, and then break, and let's say a default value, so default console.log just a regular day. So let's run this code and see what it outputs. So since it is the day's value is Tuesday, the matching case is this one, so it executes this corresponding code block and prints out it is a Tuesday. And if I were to change this value to Sunday, let's see, it outputs it's a weekend, and even if it is Saturday, it'll still output it is a weekend. So you can apply multiple cases and execute the same code for multiple cases in this way. Now let's see if we omit this break statement right here, what will happen. So let's say I change this case to a Tuesday once again, and let's see what's the output. So as you can see, it is a Tuesday is also printed, but this case, even though it is not matching with our variable, this code is being run since it is propagated down here, and this is called falling through to the next case. So that's why it is important to include the break statement inside the case statement or case block. So this is the switch case statement in JavaScript, if none of the matching value is present, so let's say Wednesday, and we should add a break statement right here, it should output to just a regular day, because this is the default value if none of the cases match. And with that, we are done with the topic of control structures for this episode. And as always, we have a mini challenge for you guys to try out. We have this code right here, and you can put your answers on what will be the output of this code in the comments below. In the next episode, we'll be discussing about loops, so make sure you tune in to know what loops are and how they work. And if you like the video, drop a like and subscribe to the channel for more videos like this. So see you guys in the next one. Hello everyone, and welcome back to our JavaScript beginner course. In the last episode, we learned about control structures, which consisted of if-else statements and switch case statements, which helped in making decisions for our code. If you missed it, you can check out the link in the description. And now we're stepping into something super important in programming: loops. Loops help us to repeat code without writing it over and over again. Think of loops like the repeat button on your music player. It lets you play something again and again without having to click it manually each time. And guess what? By the end of this episode, you'll be looping like a pro. Now, let's dive in and learn how to loop through things efficiently in JavaScript. First of all, what is a loop? A loop is a block of code that runs automatically multiple times without having to repeat it manually. Imagine you're in a classroom with 30 students and you need to give each one a pen. Instead of saying give pen to student 1, give pen to student 2 manually over and over again 30 times, you can do it in one shot with the help of loops. In JavaScript, there are three main types of loops that we'll learn today: the for loop, the while loop, and the do while loop. So let's get started with the for loop first. The for loop is the most common loop that you will be using in JavaScript, and it's perfect for when you know exactly how many times you want to repeat something. And here's the basic syntax for it. So for let I equals 0. This is the initialization part where we set a loop variable that is I, which can stand for iteration equals 0, and then a condition I is less than 5. That is, this loop will be run as long as I is less than 5, and then an increment value for I. This I++ means that after each iteration of the loop, I will increase by 1. So let's say this for loop runs a code called console.log I. That is, it prints the value of I out to the console. Simple, right? Let's see this in action. As we can see, during the first iteration, the value of I is 0, and it prints out 0 onto the console. The loop finishes, and the value of I increases by 1 when the loop finishes. The next iteration, the value of I is 1, so console.log1 is printed out to the console. After the second iteration, the value of I is increased by 1, so 1 plus 1 is 2. So it prints as console.log2, so 2 is printed, and so on until 4. After the fifth iteration, when the value of I is already 4, 4 plus 1 equals 5, and it checks the condition once again. Since 5 is not less than 5, the iteration of the for loop stops. And while this is a simple iteration of the for loop, the value of I can be used for more purpose than just printing out to the console. Let's say we declare a variable at first called let sum equals 0, right? And then we make use of the for loop to increase the sum during each iteration. So sum plus equals to I. Now what this does, if you're not familiar with this, is it adds the value of I to the sum in each iteration. If the sum is 0 at first, it adds the value of 0 first, so 0 plus 0 is 0. And then during another iteration, 0 plus 1, which will be the value of 1. Which will be the value of I, so the sum will be 1. And then 1 plus 2, and then 1 plus 2 plus 3, so it's like that. Oh, this will not compile to anything because I've not printed out the value of the sum. So console.log sum. So it prints out 10. And I'll demonstrate what is happening during each iteration of this for loop. So at the beginning we have the value of sum is 0. Don't mind my handwriting. Sum is 0, and the value of I is also initially 0 since we have declared it to be 0. And during the first iteration, I, that is 0, is added on to our sum. Sum plus equals I means I, that is 0, is added on to our sum. After this iteration, the value of I increases by 1. So the value of I becomes 1, and then 1 is added to our existing sum. And then in a similar way, 1 becomes 2, the value of I becomes 2, then 3, and then 4. And all of those values of I are added to our sum during each iteration of the for loop. And when the value of I becomes 5 after the last or fifth iteration, the for loop checks the condition, that is 5 is not less than 5. So since this condition is false, our loop will stop, and the value of sum is increasing simultaneously during each iteration. So the value of sum will have reached 10. So console.log will result 10. And that is how this for loop is working. And next we'll see how while loop works. A while loop is a loop which repeats a block of code as long as the given condition is true. But there's one thing to remember. If the condition never becomes false, you could end up with an infinite loop. And we'll see what that is later in the video. So let's look at the syntax for a while loop. For a while loop, you have to declare the loop variable outside the while loop, and its syntax is like this. We initialize the variable like in the for loop, but outside the while parentheses. So this initialization of the loop variable, and then while I is less than 5, this is the looping condition, we can type console.log I. Now see, if we don't add an increment value, that is I++, after the code to be run, we'll be stuck with I's value as 0. So as long as I's value is less than 5, the loop will continue running and looping again and again. So in order to break out from the loop, because after a certain number of iterations, the value of I will be larger or equal to 5. So to break out of the while loop, we have to add an increment or a decrement condition. And a decrement condition would be typing out minus minus, but in this case, if we type out minus minus, it will certainly go on to an infinite loop, because 0 will become -1 and -2 and so on. So I's value will always be less than 5. So in this case, the increment value should be implemented, that is I++. So let's see what this will output. So as you can see, as in the for loop, we have outputted 0 because the value of I is initially 0, and then 1, 2, 3, 4 with a similar logic of the for loop, but the difference is that you have to initialize the variable outside, and the while, after the while keyword, inside the parentheses there is only the condition. No initialization, no increment value. There is the condition, but increment and initialization are not inside the parentheses. So we have to keep this thing in mind. So that being said, if I were to remove this increment line right here, that is I++, what would happen is I would always be 0. So it will output 0, then check the condition, as in 0 is less than 5, then again output 0, check the condition again, 0 is less than 5, so again output 0, and so on. So I'll demonstrate this, but let me just copy this code and remove this, and I'll show you what happens. I'll open another tab just in case, because running this on your browser console might freeze your browser and make it crash. So I'll have to close it immediately and go to the next tab. So let me open code in this as well. So let's run this. So as you can see, it is constantly outputting to 0, 0, 0, 0, and it might crash my browser in a while. So I will close it and go on to JavaScript again. So that is what happens if we forget to increment the loop variable. We have to increment this in order to exit out of the loop, and I hope that is clear from the example before. Now let's take a look at the do while loop. This loop is a bit different because it always runs the code at least once before checking the condition. And here's the syntax for the do while loop. I'm going to erase this and type out do, then the code to be run at least once, that is console.log I, then incrementing the loop variable, and then only checking the condition, that is while I is less than 5. So it prints out the value of I at least once, increments it, then only it checks the condition, that is if I is less than 5. If I is less than 5 is true, then it runs the loop once again, and then rest is like the execution of the while loop. Let's run this code and see how it outputs the values. So from this observation, it seems like it is working like the while loop, so you might not be able to tell any difference. But if I were to change the value of I to 50, which is way greater than 5, and this condition is not true, it would still output to 50. Because the code inside the do block is run at least once, and then only it checks the condition. So console.log I, that is 50, is printed out to the console, then it checks the condition, and because it is false, it exits out of the loop. That is about it for the do while loop. You can try it out with your own condition and with your own code, but now we'll be moving on to the topic of break and continue statements inside loops, which are two important tools to control the flow inside loops. The break statement stops the loop entirely, while the continue statement skips the current iteration and moves on to the next one. So let's see with an example. I'm going to apply a for loop called for let I equals 0, initialize I at first, I is less than 10, our looping condition, and our increment I plus plus. Let's say it if we are going to apply an if condition, if I is equals to 5, it'll break out of the loop, or else it'll print out the value of I. So what this loop will do is it'll print out the values of I from 0 to 4, but as soon as the value of I becomes 5 through the increment, it'll break out of the loop since the break statement is used. So let's see this in action. As you can see, 0, 1, 2, 3, 4, that is the value of I from 0 to 4 is printed, but as soon as the value of I reaches 5, it breaks out of the loops and the execution of this console.log stops. Now if I were to replace this break statement with a continue statement, what would happen is it would reach the value of 5, then it would skip the iteration for the loop, so all of this block, the rest of this block would be skipped, and it would move on to the next iteration, that is it would print the value of I starting from 6 all the way to 9. So let's see that in action as well. So here the value of when the value of I reaches 5, it skips the iteration and starts again from the next iteration, that is when I reaches the value 6. So I hope that is clear from this example. So I hope the use of break and continue statement is clear from this example. And that about sums it up for today's episode on loops. We discussed about for loops, while loops, do while loops, and even the break and continue statement. So before we wrap it up, we have a small challenge for you guys to try out. You have to guess what will be the output of this code right here, this while loop, and put your answers in the comments below. In the next episode, we'll be discussing about functions and how they can help us organize our code better. If you found this video helpful, do hit a like and please subscribe to our channel and drop your questions in the comments. We'll see you guys in the next one. Hey guys, welcome back to our JavaScript beginner course. In the last episode, we explored loops and iterations on how to repeat code efficiently with the for loop, while loop, and the do while loop. We even learned how to use the break and continue statements to control our loops. If you missed it, be sure to check out the link in the description to watch the video. And today we are going to dive into a super important concept, that is functions in JavaScript. Functions allow us to group our code into reusable blocks, making our programs cleaner and easier to manage. And in this episode, we'll be covering functions declaration versus expressions, arrow functions, and the parameters and return values that I use in functions. So let's get started and level up our JavaScript skills. First of all, what are functions? A function is like a machine that takes in inputs and does some work and then gives an output. For example, let's say you have a coffee machine and you put in water and coffee beans as input. It does some work and gives you a cup of coffee as an output. In programming, a function is a reusable block of code that performs a specific task, and you can call the function whenever you need it. And there are two main ways to define functions in JavaScript, that is function declaration and function expression. So let's start with function declarations at first. A function declaration is the traditional way to define a function in JavaScript, and here's how it looks like. You have to first type out the function keyword, followed by the name of the function, that is greet for now, a set of parentheses for passing in inputs or parameters, and then open a pair of curly braces for the function code. So what I want to make this function do is print out hello world onto the console. Hello world. And the way to execute a function is to call it. And how you call a function is by writing its name, followed by a set of parentheses where you want to pass in values. For now, it doesn't take any inputs, so I'm not passing in any parameters, that is values or inputs inside the function while calling it. So it should print out hello world. Now, if I want to create a function which greets the user by taking the name of the user as an input, I would have to define a parameter called name for this function and put it inside the parentheses. This name parameter can now be used anywhere inside the function. So I'm going to use string concatenation to print out a greeting with the username on it. So let me remove hello world and just add an empty space right here, plus name and then an exclamation mark. So if you have defined a function with parameters, you need to pass in arguments, which are basically parameters but for calling the function, and they are the real values that are passed into the function in order for them to be used in place of the predefined parameters. So if I put in Sam as an argument when calling the function, it takes the place of the name parameter, and subsequently instead of name, Sam is set to this parameter right here. So it should print out hello Sam. So let's see if it outputs that. So you can see that it outputs hello Sam. Now if I were to type anything inside the string, suppose haha, it would print out hello haha because it takes the place of the name parameter. This argument takes place of the name parameter and it is used in its place. Parameters can be more than one as well. So if I were to type name1 and name2, I would have to pass in values such as haha and Sam. It's best practice that if two parameters are defined in the function, you should call two arguments while calling the function. And they are in sequential order, so haha takes the place of name1 and Sam takes the place of name2. So if I were to type hello name1 and then plus name2, it would output hello haha then Sam because this is in place of name2. Now if I were to omit Sam, this value would result in undefined. See? So we should define arguments when calling a function, and the number of arguments should be equal to the number of parameters defined. And that is about it for function declaration. Now moving on to the function expression. A function expression is when you assign a function to a variable. That is, it is similar to a function declaration but with a simple difference, and here is the syntax for it. I'm going to create a variable called greet, and I'm going to assign a function to this variable, function, and then console.log hello world. And then in a similar way to function declaration, to use the function you have to call the variable name. So it prints out to hello world. And notice that the function does not have any name for it since it is assigned to a variable already. And this can be taken as the function name as well. The variable name can be taken as the function name. And the function which does not have any name is called an anonymous function. And if we want to use parameters for this, we can use parameters in a similar way to function declaration. That is name, and then instead of hello world, we can use the place of name. And when calling the function, you have to pass in arguments as we discussed earlier. So hello Sam, and it will output to hello Sam. So you can use both function declaration and function expression, and it is up to you. And now we'll be moving on to arrow functions. An arrow function is a shorter way to write functions in JavaScript, and they are especially useful when you want to write small functions in just one line of code. And this is the simple syntax for an arrow function, which uses the concept of function expression. That is, it assigns a function to a variable, and a set of parentheses followed by the arrow symbol, which is equals to and greater than, and then curly braces is the arrow function syntax. And we use the arrow symbol to separate the parameters, if any, from the function body, that is the curly braces. So there are some differences between the arrow function from the function declaration and expression. There is no use of the function keyword, and I'm going to demonstrate the use of the arrow function. So let me remove this, declare the same variable const greet and equals to parentheses, the arrow symbol, that is equal to and greater than, curly braces, then console.log hello world. And we have to call the arrow function before running it. It prints out to hello world. And if your function has only one line of code, then the arrow function can be even shorter. That is, it doesn't have to make use of the curly braces if it has only one line of code. In the above example, we use only one line of code, so we don't have to use any curly braces, and instead it can be all in the same line. That is line 2. So this is an arrow function in itself, and it outputs to the same code or the same result. Now if we want to make use of parameters, we can type in parameters here, hello name, and then the same way as before, plus name, and it will output. We have to be careful while using the parameters because we have to pass in arguments as well. Hello Sam. I forgot to add a space here, so it should output to hello space Sam. So this is a way to use an arrow function. It helps you to write shorter and cleaner code which is easy to read. And now we'll be moving on to the concept of returning functions or value returning functions. And value returning functions make the use of return values. The return values are the outputs that the function gives back after it's done processing. And here is an example of a function that adds two numbers and returns the values. So I'm going to use function declaration for this. Function add, with the parameters being a and b, the two numbers to add. And let's say return is a keyword. It returns the value of a plus b. And if we call the function and assign it to a variable called result equals add, suppose the two numbers we want to add are 2 and 3, then we print out the result variable, we can see that it outputs to 5 because a and b are occupied by 2 and 3 respectively, and 2 plus 3 is returned to this place right here and it is stored in result, so it outputs the result. Now if I type out plus 1, it should output to 6 because this holds the value of 5, that is the sum of a and b, that is 2 and 3. This value is returned to the place where the function is called with the arguments, and it can be used as a value as well. So this can be assumed as 5. 5 plus 1, it should output to 6. So that is the concept of returning values, or returning value returning functions, which makes the use of return values. And if I were to write this function in the form of an arrow function, I would do it like this. I would have to remove the function keyword, since the arrow function does not need a function keyword, declare a variable called add with the const keyword, and then equals to the parameters in the parentheses and the arrow symbol. Now, since I have used the curly braces, I should use the return keyword, and let's test this by changing the value here to 2. So this should output to 7. And if I were to write this all in the same line, since it is a single line of code, I would not need to use the return keyword at all, since it automatically assumes that this expression is returned. So this should work the same with the arrow function. As you can see, no return value is used, but since it is a single line of code with no code blocks, as in no parentheses, it does not need a return keyword. So this works as such. And this is how you use arrow functions with return values. That was it for today's episode. Before we wrap up, we have yet another mini challenge for you guys, and in this challenge you have to guess what is wrong with this code below. You can write your answers in the comments. And just for a summary, today we learned about function declarations, function expressions, arrow functions, and return values. And in the next episode, we are going to be learning about objects. So make sure you tune in. If you like the video, drop a like and hit that subscribe button, and we'll see you guys in the next one. Hello everyone, and welcome back to our JavaScript beginner course. In the last episode, we dove into functions in JavaScript, from function declarations to expressions, how arrow functions are declared and work, and how to use parameters and return values. If you missed it, as always, the link is provided in the description and you can go check it out. But today we are going to discuss about arrays and objects, two core concepts in JavaScript. Arrays let us store multiple values in one variable, whereas objects let us store related data in key and value pairs. So in this episode, we'll be covering the creation and use of arrays and object properties and methods. So let's jump right in and see how we can make our code more organized and powerful with these. So first of all, what is an array? An array is a special type of variable that can hold multiple values. Think of it like a list. You can store all kinds of things in an array, such as numbers, strings, or even another array. So they are super useful when you need to store a collection of items. Think of it this way. Suppose you have a small group of friends, 10 members, and you want to store their names in a variable. Now, it's tedious to create 10 separate variables to store each person's name, right? Well, an array is a special variable which can store all of those names in a single variable. So let's explore how they are declared and how they are used. I'm going to declare a variable for the array called letFruits. I'm using the let keyword since we have the option of updating and removing items from the array as well, which we'll be exploring later. So letFruits equals to mango, and then banana, apple, and an orange. So this is how you declare an array and store values inside it. In this case, I have stored 4 strings. You can store any data type you want, may it be numbers, strings, or boolean values as well. So if I want to access any one of these values, I will have to use the concept of indexing, which is giving a number to each of the items in an array. So an indexing starts from 0 in JavaScript, like in many other programming languages. So this would have, mango would have an indexing of 0, then 1, 2, and 3. So if I want to print out this specific value of this array, fruits, I would have to type out console.log fruits, and the indexing name. So 0, 1, 2, 2. Now it should print out apple. So this is how you access a value inside an array. Now let's look at some useful ways to manipulate arrays, like adding, removing, and changing items. To add a new item to the end of an array, use the push method, which is writing the name of the array, fruits dot push, then a set of parentheses, and the data that you want to add to an array. So in this case, I'm going to add a string pineapple. Now what this does is it pushes the value that is pineapple, or it adds the value inside the array, but it adds the value at the last place. So when we type out console.log fruits, it'll print out the updated array. So as you can see, pineapple is added to the end of the array. Now if you want to remove a value from the array, you can use the pop method. That is writing the name of the array and dot pop. What this does is it removes the last element of an array. So in this case, orange is not the last element since we have added pineapple. So if I type out fruits.pop, pineapple will be removed. Let's see if it has worked by console.log fruits. So you can see that pineapple has been removed. Now we know how to add an item or to remove an item, but what if I want to change the value of the item at index number 1, because 0, 1, to another value? What if I want to update this value right here? Well, I can achieve that by directly accessing its index and assigning it a new value. So if I type out fruits, let's say I want to change the first value, mango, fruits 0 equals kiwi. So what will happen is it will update the array with this value at index number 0. So if I type out console.log fruits, it should print out to kiwi, and that is evident here. So as we can see, we can add values, remove values, and even update values from any indexing in an array. And because of that, arrays are super flexible for storing and modifying collections of data. Now arrays are super nice to store linear data, but what if you want to store data that are related to each other? Kind of like a dictionary where each word has its own meaning. Well, to organize related data, a powerful way is to use objects. An object is like a container that stores data in key value pairs. You can think of it like a contact card in your phone, where each contact has a name, number, and email address. And here's how you would create an object in JavaScript. Declare a variable, let's say person equals, well, declare a set of curly braces, or type out a set of curly braces, then declare the key and value pairs. Suppose a name can be a key, followed by a colon, and then its value. Suppose Alice. A comma to separate the keys, and another key, that is age. The age might be 25, another comma, and then suppose email. Email can be a string, Alice @example.com. Well, this is how you create an object in JavaScript. It has keys, that is these unique values. The keys should be unique, and the values stored by the keys. To access the values in objects, we make the use of keys. If I want to access the name of the person, or the person variable, or not even a variable, a person object, I would write person. Well, if I want to print out the value, console.log person.name. This accesses the name, and person.age accesses the age. Now Let's see. So it prints out Alice for person.name and 25 for person.age. Objects allow us to store and organize data in a more readable and structured way, since we know that Alice is the name of the person and 25 is the age of the person, and this is the email. Well, what we wrote here can be named as properties of the objects, since the property can include name, age, email, basically any key and value pair. An object inside JavaScript can also have what's called a method, which are functions that are stored as properties inside the object. And here's an example. For the same person, that is Alice, we can write a function inside a key. So greet function console.log hello, my name is plus this, which is a keyword in JavaScript which refers to this person, as in this object right here. This refers to the object, that is person, dot name. This keyword is used to specify the object for which the method is being created, or for which the function is being created. Since this function is inside the object person, this refers to person, and it will output to the person's name, because person.name is accessing this key, which outputs to this value. Now if you want to call the method, we can use the name of the object, that is person, dot the method name, greet. And you should not forget to add a comma after each key value pair. So you should keep that in mind, otherwise you can run into a syntax error. Now if we want to call the method, we have to call it like this, the object name and the method name, and then let's see how this runs. So hello, my name is Alice, since this dot name refers to person.name. So as always, before we wrap up, here's a challenge for you guys. You have to create an object named car with properties like its company, model, and year, and add a method called carinfo that prints out the car's information like this. This is a year, company, model. So do try it out and drop your answers in the comments below. Just for a quick recap, we learned about arrays and objects and what are object properties and methods. So in the next episode, we'll be diving into error handling and debugging, how to handle mistakes in our code and to fix them quickly. So make sure you tune in. And if you found this video helpful, don't forget to drop a like and subscribe to the channel. And make sure you ask your questions in the comments, and see you guys in the next one. Hello everyone, and welcome back to our JavaScript beginner course. So far we have covered some exciting topics such as variables and data types, operators and conditionals, loops, iterations, functions, scopes, arrays, and objects. And today we are going to dive into the concept of error handling and debugging in JavaScript, which is an essential tool for every JavaScript developer. What you'll learn today is common JavaScript errors and how to fix them, using try-catch for error handling, and debugging tips and console tricks. So let's get started with the first topic, that is common JavaScript errors. One of the common errors that you might face is a syntax error, which is mistake in the code structure. Suppose you are supposed to write console.log hello world, but then you miss a parentheses, or to end the parentheses. Now usually code editors like VS Code and our own code in compiler closes the parentheses automatically for you as soon as you open them. If this happens, it might result in a syntax error. So you can see that syntax error is occurred. Now yesterday what happened with me while recording a video for JavaScript objects was that I forgot to add a comma after I defined a property of the object. Suppose let person equals name is suppose Alice. Now I forgot to add the comma and define a method for it, like greeting. or greet equals or colon function so this will result in a syntax error as well, because there is no comma after this property, so it says unexpected identifier. So if I put a comma, this should be resolved and not output to anything, since we have not printed anything out. So you should be careful and check if your syntax is correct or not for your code. Another type of error that you might encounter is a reference error, which is a case where you use a variable that has yet to be declared. For example, let me remove this and type out console.log age. Now you might notice that we haven't declared a variable called age yet, so it will result in a reference error. So reference error, age is not defined. In order to avoid this, you should make sure that the variable that you are using or referencing is already defined, or at least declared. So equals 25. So it will resolve the reference error. And remember, we used to put null values for the variables that we wanted to declare but did not know what value to put in. So if we even declare a variable and put its value as null, at least the reference error won't occur and it will output to null. So make sure that you have defined your variable before you reference it or before you use it. Moving on to the next type of error, we have type errors. Type errors are the errors that occur when you try to use a value incorrectly. So let me demonstrate with an example. If I define a variable called let num equals to 5 and then use console.log num dot to uppercase, which is a method for strings, it will output to a type error. So type error num.toUppercase is not a function. So we should use data types appropriately. Now if I type out Alex instead of a number data type that is a string, it should output to uppercase Alex. So in order to avoid type errors, make sure you're using methods on the correct data types. And these were the different types of errors that we can encounter during programming in JavaScript. Now, what if we could prevent our entire program from crashing when an error happens? That's where try-catch comes in. Instead of letting the entire program crash, JavaScript catches the mistake and handles it gracefully. And let me show you how. This is the syntax for a try-catch in JavaScript. You write the try keyword, then open a block of code with curly braces and type out the code where an error might occur. Let's say we type out console.log x. Now this will result in an error because x is not defined yet. So this will result in a reference error. Now JavaScript tries to execute the code inside the try block, and if everything goes well, great, it moves forward. But if an error occurs, it immediately jumps to the catch block. So catch, and we have to define a variable, let's say error for this. Now what happens is, if an error occurs, all the details about the error are stored in this variable right here. And open the catch block with curly braces and console.log and error occurred. And then error dot message, which contains the actual error message for the error that occurred. And this catch block prevents the program from stopping unexpectedly, and instead of crashing, we get a helpful message. So let's see what this outputs to. So as we can see, an error occurred, x is not defined. This is the error message that is printed out from console.log. So we should use the try catch block to handle errors gracefully, and it gives you details about what went wrong, and without it, errors can crash your entire program. So thus we should use the try catch. Now just a heads up, it is not absolutely necessary to use console.log inside the catch block. The catch block is to write code that you want to execute in case of an error. So if an error occurs and you want to execute a specific code, you can include it inside the catch block, and it can be anything like alert or any other function. This is just to know what type of error occurred and a useful tool in JavaScript for development. And that is it for try catch. Now that we know how to handle errors, let's talk about debugging. Debugging is the process of finding and fixing issues in our code. So effective debugging saves time and helps us write cleaner and more reliable programs. Let's explore three essential tools that are console.log, console.error, and debugger. First, using console.log to track values. So let's say I have declared a variable called let total equals 10 plus 5, and I type out console.log total is total. So it is printing out total is 15, so we know that the value 15 is being stored in total. Now console.log is very useful to print messages onto the console, which helps us to track the flow of the execution, and it also helps us to verify whether variables are holding the expected values at different points of the code, and we can use it to check values on step by step while developing and testing our code. So if an error occurs somewhere, we can test up to which point are values being printed out as expected using console.log. So this is a very useful tool in debugging. For example, if you want to see, if we update the value of total right here, and we print this line only at the end, it will output to your total is 25. Now suppose we didn't know what value total was holding up until this point right here above line 3. We could just write console.log to check what value total is holding. So by using console.log, we can find out that up to this point of the code, the value that total is holding is 15, and it is updated later. So console.log is useful for these situations. The next method that is useful for debugging is using console.error to highlight errors. So unlike console.log, console.error is used specifically to log errors, and it displays messages in red in most browsers' DevTools, which makes it easier to identify and distinguish errors from the regular logs. If your code encounters an issue, you can use console.error to provide a clear feedback. So I'm going to demonstrate it with a small example. You can write age, let age equals to -1. Now if age is less than 0, then console dot error age cannot be less than 0. So if you have a certain condition that will result in an error, you can provide a console message which says age cannot be less than 0 in this case. So it should output to age cannot be less than 0, since age is less than 0 here. Now if I were to try this out on VS Code, just to show you an example, open VS Code, the previous folder that we opened, that is JavaScript and script.js. I'll remove this and paste this here. I'll show you the difference between console.log and console.error. So console.log age cannot be less than 0. Let's save this and run this on the live server, and then we'll go on to inspect to see the DevTools. So you can see that console.log prints out this plain message, while console.error specifically highlights the error with a red message box saying age cannot be less than 0. So this is how you use console.error to highlight errors. So hope that's clear. And up next and last, we have debugger for step-by-step code execution. The debugger statement is a powerful tool that pauses the execution of your script at the specified line when running in a browser's developer tools. So I am going to show you this through the help of VS Code once again. Now, if I were to declare a variable called let sum equals 0 and then let I equals to 0, this is our loop variable, while I is less than 4, let's say, or 5, we can update the value of the sum plus equals I, and then I plus plus, and let's say I want to see the sum at the end of the loop, console.log sum. Now if I want to check the value of sum and I during each loop cycle, I may want to put the debugger keyword here. Now I'll show you what this does in a bit. It helps us to step through our code line by line and inspect variables and their values at specific points. So I'll show you this by opening the live server and then going to inspect. Now if I go to sources and reload, we can see that this website is paused in debugger, which helps us see at this point the value of I and sum are both 0. Now if I go on to the next point, step over next function call, we can see that the value of sum at this point is still 0, since 0 is being added to the sum, the value of I. At the next point, we can see that the value of I is still 0. Now after this point, the value of I should increase by 1, and let's see if this happens. So we can see that in the next iteration of the loop, the value of I is updated. Now when I reach at this point once again, the value of sum should be 1. So sum is equal to 1. So it is evident from this that we can check the value of our variables at specific points of the code and observe how the program flows and where potential issues might occur. So this is extremely useful to debug and find out errors, or just to check values. I hope it is clear from that example as well. So using these tools effectively will help you catch and fix bugs faster, leading to smoother and more efficient coding. And that is it for debugging. So before we wrap it up, as always, here's a fun challenge for you, which is to write a function that takes two numbers as input and divides them. And you can use the try catch to handle errors when dividing by 0. And I'm going to provide you a small hint. This is the hint, more like the full code, and I'm giving this as a hint because you have to find out what the throw new error line does, this if condition right here. And in the next episode, we'll be talking about JavaScript ES6 features, so make sure you tune in, hit a like and subscribe to the channel, and we'll see you guys in the next one. Hey guys, and welcome back to our JavaScript beginner course. In the last episode, we covered error handling and debugging, which is an essential skill for every developer. And today, we are going to learn about some powerful, modern JavaScript, that is ES6 features. Features that make coding easier and more efficient. Now, we have already discussed about some of the features like letConst, which are the concept of changing or updating the variable and defining its scope, that is block scope for this case. And we have also discussed about arrow functions, which help to make our function syntax shorter and easier to read. And what we'll be learning today is about template literals, that is, they help in better string handling, destructuring, and spread and rest operators as well. So let's get started with template literals at first. So what template literals are is they allow you to create dynamic strings easily using backticks. And backticks are the symbols that are present in this area of your keyboard right here. I have put a representation of your keyboard and it should be right here. And I am going to demonstrate how they allow us to create strings, dynamic strings, easily. So I'm going to show you an example by writing a variable name called let name equals Alex, for example. And suppose I want to print out hello Alex. Now in previous versions, or previously how I've shown you to do this is by using the plus operator to join strings. So I would type out hello, then plus, and the variable name, that is Alex, will be stored here, and it should print out hello Alex. Now this is tedious since we have to exit out of the string, then use the plus operator, then the variable name. So in order to easily insert variables, we can make the use of template literals, which is done by this method. Create a set of backticks and then write hello, and in order to access the variable or insert the variable value, you can use the $sign, then a set of curly braces, and then the variable name. And how this helps us is it takes the place of the variable, or it inputs the value of the variable. So hello Alex. So why use template literals? It is easier to read and write as well. It allows multi-line strings. So it should print out all this. It should allow multi-line strings as well, and it allows us to easily insert variables. So this is one of the features of ES6. The next feature we have is destructuring, which helps us to extract values easily. So destructuring makes it easy to extract values from arrays and objects, and I'll demonstrate it with each one of them. So let me create an array called const numbers, and then put some numbers in it like 10, 20, and 30. Now let's say I want to access the values of the array but without indexing. So I can just create const and then first, because I want to access the first value. It is in order, by the way, so second. So second equals the array I want to access it from, so numbers. Now if I type out console.log first and second, it should print out the first and second values, so 10 and 20. Now this is just a variable, so it can be anything like A and B as well. It doesn't have to be first and second specifically. Now if I type out A and B, it should give us the same result. So this is destructuring in arrays. So in the case of an object, let me create an object called const user equals name Alice, and then comma, because I want to separate the properties, age 25. Now if I want to access the values of the object without using dot notation, I can do it like this: const name age equals the object I want to access it from, so user. Now console.log name and age. Now these are the key names from the object we want to access it from, so it should print out the values of the keys, that is Alice and 25. And this is destructuring in objects. So why destructuring? It helps make data extraction quick and clean, and it avoids repetitive dot notation, since if I wanted to access the values name and age, I would have to type out user.name and user.age respectively, and this is easier. So this is destructuring in JavaScript. Moving on to the next feature, we have the spread operator and the rest operator, which are both symbolized by these three dots right here. So the spread operator helps us to expand arrays and objects, and the rest operator gathers multiple values into a single array. And let me give you a demonstration with an example. So I'll create two arrays, const arr1 equals, let's say 1, 2, and 3. Now if I want to create another array by including the first array in it, I can use the spread operator. So const arr2 equals dot dot dot, and then the name of the array you want to include or merge, that is arr1, and then 4 5. Now let's print out and see what value is contained by array 2, that's arr2. So console.log arr2, and we can see that the first array has been merged into the second through the use of the spread operator. And this is the use of the spread operator in an array in JavaScript. Moving on towards using the spread operator in an object, we can create two objects and merge them into one. So let's create const object1, which will be equal to name, and then as always Alex or Alice, and close this. Const object2 equals age 25. So, and we can create a third object, const merged equals dot dot dot, that is this spread operator, object1, because we want to merge both object1 and dot 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 object2. So let's see if the spread operator has worked in this case. Console.log merged. So we can see that both the object1 and object2 is merged into object merged since we have used the spread operator. And this is the use of the spread operator. Now moving on to the rest operator, it is for when you want to merge all of the different items into an array. So suppose I have a function which takes in an array, which should take in an array called sumAll. So I'll use the rest operator in this case, dot 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 numbers, so that any number of arguments that are passed into this function when calling it are stored in an array. So open this and console.log numbers. So let's see, when I call this function sumAll with 1 2 3 4 5 as arguments, there are 5 separate arguments. Now let's see what this will print out. So since the rest operator is used, all of the values that are passed into this function are stored in an array. So this is the use of the rest operator. The rest operator allows the functions to accept an unlimited amount of arguments, as we can see here. No matter how many arguments we add in this, it will always keep on adding like this. So it makes function parameters more flexible. And why use the spread operator? It helps us to manipulate arrays and objects easily. And that is about it for the features that we are going to be discussing today. And as always, we do have a mini challenge for you guys, and the challenge is to write a function which takes any number of arguments and returns the maximum value using the rest operator. And you can drop your answers in the comments below. And the hint for this challenge is to use the math.max method, which returns the largest number from a given set of numbers. And it doesn't take arrays as an argument. However, you can use the spread operator to pass an array to math.max. So in the next episode, we'll be discussing about asynchronous code in JavaScript that includes JavaScript promises and async and await. So make sure you tune in for that. And if you like the video, hit a like and smash that subscribe button. And check out coding.com for interactive courses. See you guys in the next one. Hey everyone, and welcome back to episode 10 of our JavaScript beginner series. And as you can see in episode 10, we are going to be discussing about asynchronous code in JavaScript. So for those of you who are unfamiliar with the term synchronous and asynchronous, let me tell you some background about JavaScript. JavaScript is a single-threaded programming language, meaning that it can handle only one task at a time and cannot run two tasks simultaneously. So it is synchronous by default. So what you mean by synchronous JavaScript is it executes code line by line and waits for tasks to be completed before moving on to the next line of code. So if something takes time, the entire script or the entire code is delayed until it is done. So everything else waits until it is done. And what asynchronous JavaScript means is it handles tasks that take time in the background. So the whole block of code is not on pause. So the tasks that take time run parallelly with other functions. Why use asynchronous JavaScript, you might ask? Well, it helps us to prevent UI freezing and enables real-time interactions such as APIs and user inputs, since these might take some time. And it makes web apps faster and more responsive as well. So in order to understand about asynchronous JavaScript, we have to first understand about the setTimeout method. So I'm going to show you an example. Suppose I type out console.log start, and then I use the setTimeout method, that is setTimeout, then open brackets or parentheses, then write the function that you want to delay, and suppose I want to delay a message called console.log. This message appears after 2 seconds. And then after the function is done, you have to set the time that you want to delay it for. So if I want to delay it for 2 seconds, I have to type out 2000, since this time is counted in milliseconds, and 2000 milliseconds means 2 seconds. So then console.log end. Now what should happen is it should print start, then print end, and then after 2 seconds it should print out this message right here. So you can see that after 2 seconds this message appears. And it is so because setTimeout makes the function that is inside the setTimeout method asynchronous, meaning that it runs in the background since it takes some time to run. And JavaScript recognizes this as an asynchronous function, so it directly moves on to the next line. And so start is printed out, then immediately end, and then while this is running in the background, after 2 seconds it prints out this message. So I hope that is clear from this example. This is the core of asynchronous behavior in JavaScript. And now that we understand delays, let's talk about callbacks, the original way of handling asynchronous tasks in JavaScript. A callback is just a function that is passed as an argument to another function, which runs later in the program. So I'll provide you a small example. Suppose I have a function called function fetch data, and I write a variable called callback as a parameter, and then we use the setTimeout method to simulate a delay for now. So I am going to type out setTimeout, and using an arrow function for simplicity, I'm going to define a function. So let's say our function fetches data. So console.log data fetched. Now if we want to perform another function after fetching the data asynchronously, we have to pass that function as an argument while calling this fetch data function, and the passed function will be executed here after this as a callback. So callback. Now let's say I want to delay this for 2 seconds, so 2000 comma 2000, and then now let's say our callback function should process the data after it is fetched. So first the data is fetched, then processed. So we should call the fetch data function with another function. I'm going to make this an arrow function that processes the data. So let's say it says processing fetched data dot dot dot. So first it will say data fetched, and then it will say processing data. Now if we want to delay the processing data, we can apply another setTimeout inside and keep this function inside, but I'm not going to do that here for simplicity. So this is how callbacks work. Now, callbacks might seem simple since it's just knowing what functions to pass as callbacks, and that is according to the order of what you want to do with the asynchronous function. So in this, I wanted to fetch the data first. So while defining the function, I fetch the data first and then passed processing data as a callback inside this function while calling this fetch data function. So it might seem simple, but it can get ugly and messy quite quick. If you have a large number of asynchronous functions that you want to execute in order, it becomes a callback hell, because all of the functions have to be nested inside one another, and that can get hard to read and maintain. So let's say we have to fetch the user data, then their posts, and then their comments. I have copied a code to demonstrate that callbacks can and will get messy at one point. So let's see the code. So this is the code I was talking about. And we can see here that 3 functions are defined, each one for a task that I mentioned earlier. Fetching user data, then getting their posts, then getting their comments. And at the end, they are called in order of the callbacks. So as you can see here, in order to perform 3 asynchronous tasks, 3 separate functions need to be defined, in which 2 are callbacks. So this is tedious to type out, and the calling of nested functions makes it harder to read and maintain the code. So callback is generally not recommended. And if there are more than 3 callbacks used, it'll just get messier and messier. JavaScript introduced promises to solve the callback hell problem. And what a promise is it is a value that will be available in the future. So it is like telling JavaScript, I promise that I'll eventually give you a value, so let me run in the background while you continue with other tasks. It can be either resolved or rejected, and we can actually define the conditions for the promise being resolved or rejected, which I'll show you in the example. It resolves with a value and it rejects with a reason. So let me show you an example. Suppose we are ordering a food in a restaurant. So the restaurant promises us, that is JavaScript, that the food is being cooked and you will be given a result. So that result can either be positive, that is resolved, or negative, that is rejected. So let's define a promise for that. My promise equals to new promise. These are the keywords, and then 2 parameters we have to define for resolve and reject. And these parameters are actually the functions which we can call later when we want to print a message when the promise is resolved and when a promise is rejected. So I will do set timeout to simulate a delay and use arrow functions. Now let's say success equals true. If success, that is if our promise is fulfilled, we will call the resolve function, and it will provide a message when the promise is resolved, that is our food is ready. Now else it will reject. So reject is being called right here. It is a function which is used as a parameter in a promise. So reject, we ran out of ingredients. So let's define a timeout value, so 2 seconds for this as well, and then close our promise. So let's say console.log order placed ... waiting for food. And I'm typing this out just to show you that this will be asynchronous since set timeout is used, and this is the initial value that will be printed since this is asynchronous. And then we have to type out the promise name to achieve results using the .then handler, and this is for when a promise is resolved. So it will receive the result value, and the result actually stores this message for which we set for a promise being resolved. So this message will be set here, and it will print out to console.log result. This code can be anything that you want JavaScript to do when a promise is resolved. So this is what I want to do when the promise is resolved for now, that is print out the message that food is ready. And if the promise fails, the reject will then pass over to this dot catch handler. So whatever the error is, this message will be stored in this error variable. So it should print out our error. So console.log error. If you want to carry out a function either way, whether a promise is resolved or rejected, you can type finally, which will make the JavaScript execute this function after it is either resolved or rejected. So finally, we can say console.log thank you for your patience. So these .then and .catch handlers will only take action after the promise is fulfilled. So if it is resolved, it will go to .then, and if it is rejected, it will go to .catch. And after either this or this is activated, then only the finally handler will work. So in order to demonstrate that, I'll type out console.log meanwhile chatting with friends. And I realize that I have made a spelling error, so let's see in how this executes. First, order place, and this should be printed as it is, and after 2 seconds the food is ready is printed out, and thank you for your patience is printed out. So from this we can observe that JavaScript ignores this .then, .catch and .finally that are promise related, and lets the promise run in the background. So this, and then immediately this code is executed, and our promise here is being resolved as the success value is set to true, and this message is stored by this variable right here, and that is printed out to the console since the .then operator or handler is working. And if this is set to false, we'll be able to observe that we ran out of ingredients. So an error is being printed out to the console, and we can observe that regardless if the promise is being resolved or rejected, the .finally handler always works. So thank you for your patience is always printed out. So I hope everything about promises is cleared with this example right here. And that is it for today's video. I hope you understand what asynchronous JavaScript is and how callbacks and promises work. And this is actually the part 1 of this video. The rest of the features related to asynchronous code in JavaScript will be explained in the next part of this video, that is part 2. So make sure you stay tuned in for that. Thank you for your attention and thank you for learning. Give this video a like if you found the video helpful, and hit that subscribe button if you want more content like this. So see you guys in the next one. Hello everybody, and welcome back to our JavaScript beginner series, episode 10, part 2. If you have watched the previous video, you might know what asynchronous JavaScript is, what callbacks and promises are, and how they work. So if you have not seen the video and have no idea about what I just mentioned, it would be better to watch that video first and then coming back to this video. So the link to the previous video is provided in the description. And in this video, we are going to be discussing about async and await and how to use fetch for modern API calls and fetching data. So let's get started with the video. Now, in JavaScript, working with asynchronous operations like fetching data from an API can be tricky. In the past, we used callbacks and then moved on to promises to handle asynchronous tasks. However, async and await provides a cleaner and more readable way to work with asynchronous code. So what is async? Async makes a function asynchronous. So this means the function will always return a promise, and we can use await inside the function. So what is await? Await is a keyword that can be used inside an asynchronous function, which is defined by the async keyword, and it pauses the execution of a promise until the promise is resolved. So if we remember from before, a promise will run in the background until it is either resolved or rejected. And during that pending state, JavaScript runs whatever the code is remained after the promise. So await pauses the execution of any other code until the specified promise is resolved. So let's see an example for that. I'll first write the async and await syntax, and I'll explain the code later. So first we write the async keyword, async function, to make the function fetch data asynchronous. And then we'll create a try catch block to easily catch errors, and console.log, let's say it's simulating fetching data, so fetching data ... and let our response equals a promise. So let's say await, since we have to wait for our promise to be fulfilled in this case. So resolve, and then an arrow function. Let's say this promise is of fetching some data, so we create set timeout to simulate a time delay, since fetching data takes some time in real life. So set timeout, resolve data fetch successfully, and let's say this takes about 2 seconds, so 2000, and then we create a catch block for an error to occur. So console.log error. So let's execute the function right here. Now here, the reason we use await in this new promise is because we have to, oh, I'm sorry, I omitted a part. We have to show the data that we received, so we have to show the response. So yeah, the reason we use await here is because we need this response variable later in the code. So in order to have this response variable, we need to wait for this promise to be fulfilled. So if we did not use the await keyword, if we did not make this function asynchronous and consequently did not use the await keyword, JavaScript would leave this promise to be resolved or rejected in the background and move on to the next code immediately. So in this case, it will output to fetching data and then data fetch successfully. But I'll show you what would happen if we did not use the async and await keyword. So let's see, fetching data and then data fetch successfully. Now if I did not use this await keyword here, our promise would still be in the pending state when JavaScript moves on to this block or this line of code. So it would output to promise pending. So it instantly outputs to promise pending because this promise is still pending for 2 seconds. So in order to prevent this, and in order to prevent variables having no values arrived yet or variables having values pending, we use the await keyword. And in order to use the await keyword, it should be used inside an asynchronous function. And if an error occurs by any chance, the try catch block handles it gracefully. Alright, so with this, I hope it is clear how async and await makes working with promises much cleaner. But what if we want to fetch data from a real API? Well, that's where the fetch API comes in. The fetch function is a built-in function in JavaScript, and it's how we make network requests, like getting data from a server or an API. And the cool thing about it is it's completely promise-based, which means that it works perfectly with async and await. And for this video, we'll be working with JSON placeholder, a free fake API for testing and prototyping. So this is the API right here. And this website provides sample data for things like users, posts, comments, and more. Kind of like a mock database that developers can use to practice API calls. It's super useful since we can fetch realistic data without setting up any backend. For example, this website or this link right here gives us details about a fake user with an ID of 1. And let's see how we can fetch and display that user's data. So let's start with a basic example. Suppose we want to fetch user data from an API, and here's how we do it using fetch and promises. So fetch, and we'll open parentheses, and inside our double quotations we'll paste the link, and then we'll use the promise handler. So dot then, this is for a response, so we'll type out response, arrow symbol, and response dot JSON. Now what response.json does is the data we have provided here, or we have been provided here with, is in the JSON format, and .json essentially converts this JSON format into JavaScript object, and in that process it returns another promise to be resolved. So for the promise that is returned by this .json method, we use another then event handler, data. So this data will be logged onto the console. Username is, let's say, data dot name. Now what happens is a response variable contains all of this JSON data that is provided here, and when we convert it to response.json, all of this is converted into JavaScript object. The difference between JavaScript object and JSON is JavaScript objects keys can be without the double quotation marks, but in the JSON format the keys are in double quotation marks, and that is the key difference between JSON and JavaScript object. And JSON is used to send and receive data from websites and APIs and more. So response.json converts this JSON data into JavaScript object notation, and this promise is returned into this data variable from this dot then handler, and this data dot name, that is this name of the data object, JavaScript object, is printed out to our console. Now let's see how this works, and if any error occurs we can use the catch, and then error, we'll use console.error, let's say for now error. Now this dot catch will catch both network errors and issues with JSON parsing, and the key takeaway from this is because fetch is promise based, we can handle it using dot then and dot catch just like any other promise. Now I'll run this using our web dev section because that will be simple, and we might face an error while trying to run it in a JavaScript compiler itself. So I'll go back and go to our web dev section and then JavaScript. So I'll paste our code here, and as we can see that username Lean Graham, which is indeed the username or the name provided by this website, is printed out to the console. Now this works just fine, but as we discussed earlier, async and await makes our code cleaner and easier to read. So instead of just chaining dot then, we can rewrite this using async await. So watch this. Async function get user data, and we'll use a try block, then let response equals await, because we are going to use fetch and we need the fetched value, and then we are going to copy this API link, and then let data equals await response dot JSON, because we want to convert it into a JavaScript object, and then console.log, just like our previous code, username, and then plus data dot name, and then catch block for any errors, and console dot error fetching data, and our error. So let's call our function get user data, and we can see that Lean Graham has been outputted to the console. Now if we try to get its username, so data dot username, we'll get this as Brett because it is the username provided by the API. So to sum it up, fetch is a modern way to make network requests in JavaScript, and it returns a promise, so we handle it using .then, or even better, async and await. And now that you know how to fetch data, you can try to fetch data from other sample APIs or just fetch a different value from this API right here. In the next episode, we'll be learning about the document object model, that is DOM. So make sure you tune in for that. And if you liked the video and found this video helpful, hit that like button and subscribe to our channel. And see you guys in the next one. Hey everyone, and welcome back to our JavaScript beginner series. In this episode, we're diving into the document object model, or the DOM. And if you've ever wondered how JavaScript interacts with web pages, this is where the magic happens. And by the end of this episode, you'll know how to select and modify elements on a web page. So let's get started. First of all, what is the document object model? It is the data representation of the objects that comprise the structure and content of a document on the web. It is a way to represent a web page in the structured hierarchical way, as you can see right here. And it can be thought of as a tree of different HTML elements, its properties, and its methods and events. So in order to demonstrate the document object model, I'm going to execute two commands in the browser's DevTools. And those two commands are going to be console.log document, which is an object which represents the entire structure of this web page right here, and which is loaded onto the browser. So this shows us the DOM structure of the web page, which is useful for understanding how the HTML is organized. So as you can see, here is the head and how the elements inside the head are organized, and this is the body, and it also contains the script and the styling. So another command which is used to demonstrate the document object model is console.log or console.dir document, and this shows the properties and methods of the document object, which is useful for understanding what you can do with the DOM with your program. So JavaScript can access and modify this structure dynamically, and now that we have an idea of what the DOM is, we will move on to DOM manipulation, which starts with selecting the elements of the DOM. And to do that, I'm going to be using VS Code and open our files that we created in previous episodes, that is index.html and script.js. So first, let's create some elements in our HTML body. So let's say I create a header or a heading element and give it an ID called main heading, and I type out this is the main heading. And then I create another element which is a paragraph. This is a paragraph. And to show you that we can select multiple elements at once, I am going to create an unordered list which has two list items having class list item. So let's say our list item is chocolate at first, and then our list item is milk. So chocolate and milk. Now let's select these elements using our JavaScript. One of the ways we can select an element in JavaScript is by its ID, and we can create a variable to store the selected element. So let's say let heading equals the document object dot, now we use the selector, that is get element by ID, and we enter its ID name in double quotations, that is main heading. And after this element is selected, we can do whatever we want with it. So let's log our heading onto the console. So console.log heading, and I'll save this, launch the live server again, So we see that our elements have been updated, and we can see that the element that is our heading selected by its ID is logged on to the console with the help of this selector right here, document.getElementById. Now we can select elements by class name as well. So let's say let items equals document dot get elements by class name. So it's already recommended, so I'll click enter, and our class name was list item. And if we log these selected items, so items, we can see that an HTML collection is logged on to the console, which is not an array but an HTML collection. So we can select elements by the class name and the ID name as well. And we can also select elements by its tag name. So suppose let paragraphs equals document dot get elements by tag name. So we have a p tag, so let's select the p tag and log that on to our console. So paragraphs, and we can see that our p tag is logged on to the console as well. And if we want to select specific items, we have to use indexing. So if I want to select milk, I'll have to use the indexing 1 for it. So if I put an index after selecting the items by class name and put an indexing called 1, it should select the value at the first index, that is 0th and first index, so it should select milk. So if we head on to our browser, we can see that a single list item has been selected, and if we go down to check its text content properties, we can see that milk, that is this element, has been selected. So in order to select a single element by using its class name, we have to use indexing. And same with the paragraph tags, since these also return an HTML collection. If there are multiple paragraph tags, you can select a specific paragraph by its indexing. But if you want to select a specific paragraph, using getElementById is more convenient, since you don't have to worry about mentioning its indexing. So now another method of selecting elements of the DOM using JavaScript is by using the query selector and query selector all. And these selectors use the CSS selectors to select items from the DOM. So let me show you what I am talking about. So if I type out let heading equals document dot query selector, and if I want to select the heading and I want to select it by ID, I have to give the hashtag and then I have to write its ID. So main heading, and if I use console.log to log on this selected item, we will get this result in the browser. So we can see that the heading having the main heading ID is selected by using the query selector. So if I want to select the items or a single item using the query selector, because query selector is for single items, and I want to select an item by class name, I can use the dot selector. So dot list item, if I type this out, item. If I sort this out, we can see a single list item has been selected and it has the text content of chocolate. So the first item that matches the class name is logged on to the console or is selected by our query selector. Now if I use query selector all for suppose let all items, it will return all of the items or all of the elements that match the class name. So all items equals document dot query selector all, and I type out the class name using dot list item and log our selected items onto the console. So all items, it provides us a node list with all of the items that we just selected with the query selector. So these are considered the modern approaches to selecting items in JavaScript because it provides a simpler, more flexible, and more powerful method to compare to our older DOM selection methods like the ones we just discussed. Document.getElement by ID, .getElements by tag name, and .getElements by class name. And using the methods query selector and query selector all allow you to use CSS selectors directly, which makes it more versatile. And since instead of using multiple different methods like the ones I just mentioned, we can use one unified method. So that is why these are considered as optimal and the modern approach. So now that we know about the ways of selecting an element, let's change its text content. JavaScript allows us to update the text inside an element using the method called innerText. So if I want to change the text of the heading, we have to select it first. So I'm going to select it using document.getElement by ID. So our ID is main heading. And now that I've selected the heading, I'm going to change its text using a method called innerText. InnerText equals hello JavaScript. I have been changed. So let's see if the text content has changed after saving this file right here and opening our browser. So we can see that the text content of the heading is changed. Next, we can move on to modifying an element's attributes, and for that we can use the set attribute and the get attribute methods. The set attribute method is to change or add attributes to an element, and the get attribute method is to retrieve their values, and I'm going to demonstrate it right now. So if I type heading dot set attribute, and in the bracket at first we have to write what attribute we want to change or add. That is, I'm going to add style and then the value. So color is red, and let's say the font weight is bold. So let's see if some changes have took place after we save and go on to our browser and then JavaScript. So we can see that its attribute has been changed, and it has been changed to red and then bold. So if we use the get attribute property, console.log heading.get attribute, and if we type out the name of the attribute style, we can see in our browser that the attribute that we had just set has been logged onto the console. And this is how set attribute can be used to change and add attributes of items after they are selected. And instead of using the set attribute, we can also directly modify the styles with the dot style property, and I'll show you how that can be done. So if I comment this out and write heading dot style and write our style value, and write our style property color equals, and then our value blue, and if we write out heading dot style dot background color equals light gray, and then we save this and head on to our browser, we can see that these changes have been applied by using the dot style property. And notice how while using the dot style property, instead of using the usual CSS syntax as in with hyphens, we use camel casing. So that is the difference between applying CSS externally with a CSS file and using JavaScript to apply CSS. It's the casing. And that's a wrap for this episode. In the next session, we'll explore how to create and remove elements dynamically and even handle user interactions with event listeners. So stay tuned and happy coding. If you like the video, you can drop a like and hit that subscribe button, and check out coding.com for awesome courses. So we'll see you guys in the next one. Hey everybody, and welcome back to the JavaScript Beginner series. In the last episode, we discussed about what the document object model, that is DOM, is, and how to select the elements of the DOM, how we can modify the attributes of the elements we selected, and change their text content. And this video is kind of like a part 2 to the previous episode of the topic of the DOM. So if you have no knowledge about the DOM whatsoever, make sure you check out the previous episode first. The link is in the description. And in this episode, we are diving deeper into DOM manipulation by dynamically creating and removing elements, and we'll also make our page interactive by using event listeners. So by the end of this session, you'll be able to modify your web page on the fly and handle user interactions like a pro. So let's get started. So first up, we have creating and removing elements. So JavaScript allows us to create, modify, and remove elements dynamically, meaning we can add content to our web page in real time, or even remove content from our web page based on user interactions. So let's start by creating an element and adding it to the page. So I'm going to open VS Code, type our default code format, and then create a heading called my list. So h2 and then my list. Well, below the heading, I'm going to create an unordered list which has the following items. Item 1. And then to copy this line of code, you can use a shortcut by pressing Alt, Shift and down arrow 2 times to create 2 more lines of code. So item 2 and item 3. And I'm going to link our JavaScript file to our HTML by using the script tag. Script src equals script.js, and then I'll head over to our JavaScript file and create an element through the method called .createElement. So pretty straightforward. I'm going to create a new item. So let new item equals document dot create element. So document dot create element, and since we are going to create a list item, I'm going to use a list tag inside this method. So this item creates a new list element in the memory. However, it is not yet added to the HTML page. It is just created and stored in the new item variable. So let's give this variable or this list item some text before adding it to the HTML. So we'll use the inner text method that we discussed in our previous episode, which changes the text that an element can contain. So inner text equals I am new here. So in order to add this to the HTML page, we will use a method called append child. Now, as the name suggests, we will append this new element or new item to an already existing parent element in the HTML file. So in this case, the parent element is the unordered list. So we have to select this unordered list tag before adding the child. So we will select the list. So let list equals document dot query selector, and then I'll put here the unordered list tag, and after the parent element is selected, we can use the append child method. So write the parent element's name or the variable that you have selected it in, and dot append child. So write the variable name that you want to append, and since we have selected and stored the item in this variable, I'll put append child new item. So let's say if some changes have took place in our HTML file. So I'll head over to HTML and then go live, and we can see that I am new here is appended to the HTML, even though we haven't put up any such element in our original HTML file. It is still appended, so hence a new element is added to the HTML. So now that we are done with adding an element to the HTML page or the HTML structure, let's try removing an element. So there are two ways to do this in JavaScript, and they are remove child and remove. So the first method, that is a remove child, kind of works like an opposite method of append child. You select an item or select the parent element, and you select another item that you want to remove through document or .query selector or any other selector of your choice, and then you remove the item. So let's say we want to remove the same item that we added to the HTML structure. So I would choose the parent element, that is list dot remove child, and then I would choose the element that I want to remove. So let's say new item, and let's save this and see what happens to our structure. So we can see that the element that we just added previously has been removed. Now, to show you that we can select any item on our structure, I'll try to remove the first element by giving it an ID. So let's say I'll give this an ID called first. So let's save this and first select that item, that is let first item equals document dot get element by ID, and I'll type in first. So list, that is our parent element, the unordered list, dot remove child first item. Let's save this and let's see the changes in our web page. So we can observe that the first item has been removed as well. Now this approach is useful when you specifically need to remove an element from its known parent. Now the second method is even simpler. Instead of selecting a parent, we can just call .remove to directly remove the element that we have selected. So I'll delete this code altogether and I'll use the remove function, so our method. So since we have selected the new item already, I'm going to write it, and the syntax goes like this: new item, that is the item you want to remove, and dot remove, and it is simple as that. And if we click on save, we'll see that the new item has been removed. So let's try this with our first item. So if I select the first item again, let first item equals, I'll use a query selector this time, document dot query selector. Now a thing that you have to keep in mind when using the query selector is you have to put in a hashtag for the ID. So hashtag first. So this has been selected. Now first item dot remove. So we have removed the first item as well. And keep in mind that these changes are only taking place when the HTML page is loaded. It does not change the actual HTML structure. So when we see the structure, it is same, and if we comment out this line, that is our JavaScript line, we can observe that no changes actually take place in the actual HTML structure. So you should keep this in mind. So the changes have took place after I uncommented the line that connects our JavaScript file to our HTML file. So .remove is a cleaner and modern approach that works in all major browsers and removes the element immediately without needing a parent. Both methods achieve the same result, removing an element from the DOM. So you can use either one depending on what makes more sense for your project. Now that we are done with adding and removing an element from the HTML structure or the DOM, let's have a look at a way to make our project or web page interactive by responding to user actions like clicks, hovers, or key presses. So JavaScript provides a add event listener method which lets us execute code when an event occurs. An event is basically user interaction or whatever happens with our HTML elements. So for that, let's first create a button in our HTML page, and we'll say button and give this an ID called click me. So click me. Let's say this button says click me, and save this and head over to our JavaScript. Now if we want to make our web page do stuff when we click on the button, we start by selecting the button that we want. So let's select button equals document dot get element by ID, and our ID is click me. So click me. And since we want to make the interaction with this button trigger change or any task to be performed, we add an event listener to the button. So button dot add event listener. This is a method. So after writing add event listener, as the first parameter, we want to write what event should trigger the function, so or the task that we want to perform. So if the button is clicked, this should trigger the event. So I'm writing click, and a function which, let's say, alerts the user. So alert warning, button has been clicked, has been clicked. So let's close this. And what this does is we tell JavaScript that when this button is clicked, we should run this function. And this method keeps our code cleaner and allows us to add multiple event listeners to the same element. And there are many such events that you can include in the event listener that you can create. So which includes mouse down, when you drag an item, when a mouse hovers over an item, or when you press a key on the keyboard, or double click, and many more. So first let's test this event listener out. I have opened this in our browser, and when I click the button, as you can see, the function which triggers the alert function has been triggered, so or executed. Now when I change this event to double click, that is denoted by DBL, and click and save it, when I click on this 2 times, so double click, the button triggers the event listener which triggers the function. So if I click this a single time, nothing happens, but if I click this 2 times, the event is triggered. Like this, there are many events that you can explore and talk about, and I would definitely encourage you to read some documentation and find out what events that you can include in or through the event listener, and do try it out on your own. So after learning about event listeners, we can move on to the topic of event delegation, which is handling multiple elements efficiently. Now imagine we have a long list of items, right? Here we have only 3, and that's valid. But if we have a long list of items and we want each one to change a color or change their color when clicked, instead of attaching individual event listeners to each and every one of the items, we can use event delegation. Attaching an event listener to each item is very inefficient, since you would have to write this block of code for the number of buttons that you have. So this is just for one button, and just for 3 buttons you have to repeat this block of code 3 separate times. Now what event delegation does is it attaches a event listener to the parent element, and it checks the condition of the child, and then it triggers an element. So if that is not clear with the explanation that I just gave, I will comment this out and show you an example. So if I type out document dot query selector, and I select our parent element, that is the unordered list, and then I add an event listener to this parent element. So let's say I'll add click event and a function which takes a parameter, that is event. So let's say if event dot target dot tag name triple equals to, which is strictly equals to li, that is our list item tag, we will change its color. So event dot target, that is the element that we have clicked or which triggers an event, dot color equals, let's say, green. Now you might already know what is going to happen. So we attach a single event listener to the unordered list instead of each list element. When a user clicks an item, JavaScript checks if the clicked element is a list element and then changes its color. This ensures that the newly added list items also get the same functionality without extra code. Now, if we had 10 separate list items instead of 3, we would have had to attach an event listener to each and every one of them. But with event delegation, we can just attach an event to the parent, check the condition of the target, and then trigger the event. So this is much more convenient and much more efficient. So let's check this out. I'll save this code and I'll click on the list item. See, it turned green. Now this will turn green as well. And if I remove our remove tag or remove method and save, we will see that the first item also appears, or the last item also appears, and if we click on this, it will turn green. Now if we add a separate element, so let's say net new item 2 equals document dot create element, and we want a list element, so li, change its text content to dot text content equals I am the newest, let's say. So if we add this on to our parent element, this event listener should attach to this newly added element as well, since it will fulfill the condition of the target staging being list. So list dot append child new item 2. So let's save this and see, I am the newest, and if we click on this, this will turn green as well, as along with every other list item inside the parent element. So this is how event delegation works. And if you're wondering about this event parameter inside this function, this is an event object that gets automatically passed to the event handler when an event occurs. So it contains the details about the event, such as the type of the event, the target element that triggered the event, which is represented by this event.target, and the information about the keyboard or mouse interactions if applicable. So this event right here represents the click event that happens anywhere inside the unordered list element, and event.target refers to the specific element that was clicked inside the list. So the condition event.target.tagname equals li checks if the clicked element is a list element, that is the li element, and if it is so, it changes the text color of that target to green. Well, congratulations, you have made it this far, but can you apply what you have learned? In the next video, we're building a practical project that combines everything from this series, so it's your chance to code along and level up your JavaScript skills. So hit that subscribe button and I'll see you there. Hello everybody, and welcome back to the end product of our JavaScript beginner series. When starting this series, we told you guys that we would be coding a real life project with the help of the things that we learned throughout the series, and today is the day for that. Today we are diving into something super exciting. We are building a task manager app or a to-do list app with the help of JavaScript. And imagine having a simple app where you can add tasks, delete them when we are done, and even fetch tasks from an external source, all using JavaScript. So that is pretty cool in my opinion. And by the end of this video, we will have a web app or a web page which is something similar to this. So in this task manager app, we can add tasks. Suppose teach our viewers how to make this. Hit enter and add this to our list of tasks. And when we are done with the task, we can click this delete button right here to remove this task from our list. And we can add multiple tasks as much as we want, remove all of them, and even fetch tasks from an API. So like this. Now without wasting any time, let's start with coding this. We have opened our coding compiler, and this is the web dev section of the compiler, and this provided here is our default boilerplate code for this video or this project, and it consists of a simple input field where we can enter our tasks, and it consists of a button which adds our tasks to the task list, and also another button which fetches API tasks from an API, and an unordered list for holding our list items. So this is the HTML code, and we have created a simple CSS file to style our heading, our input field, our add task button, and our fetch API task button. So since we have our main focus on JavaScript, we will not be focusing on these. These files will be provided to you guys in the description. And let's get to our JavaScript code. So first things first, in order to make this website interactable, we have to select each individual element that we want to interact with. So for that, I'm going to select our input field, our add task button, our fetch API tasks, and our task list, which is in the HTML. So for that, I'm going to create 4 variables to select our necessary elements. So const task input for our input field, const add task button, as the name suggests, for our task button or add task button, and a selector for, or a variable for selecting our task list itself, and finally a variable for selecting our fetch task button. So fetch task button. So I'm going to select each of these elements which I have mentioned by using a selector called document.getElementById, which we have discussed in our previous lessons. So if you don't know about that, please do check it out. So task input equals document dot get element by id. So I'm just going to write down this for each of the variable that we have defined. So Control C, Control V, Control V, Control V, and I'm going to check out what IDs do these elements have. So for our input field, we have given it an ID of task input. For our add task button, add task, our task list ID, and for this button right here, we have given an ID fetch task. So I'm going to write these IDs in our selectors. So task input, and then our add task, our task list, and our fetch tasks. So fetch tasks. Now once we are done selecting our necessary elements, we can head over to making them interactive. Now in order to do that, we will have to create a function which takes the task that we enter in this input field, and on the click of this button, it will add that task onto our task list. And for that, it should create a new list element by fetching the value that is entered into this input field. So we have to create a function which will create a list element first and then append that element to our unordered list. So I want you guys to pause the video and try it out for yourself, and if you have any difficulties, you can always check it out right here. So let's get on to it. First, we'll create a function by using the function keyword, and let's name this function add task. So let's say we have to store whatever the user or we ourselves enter inside this place into a variable. Let's create a variable for that, for storing our input. So const task text, let's say, equals. Now we have already selected this input field right here from our DOM. So this field is called task input. So I'll say task input, and for fetching its value, we'll write dot value, and we have to create an element first. So const li equals document. We create an element through the create element method. So document.create element, and our element is a list item, so we'll give it a tag of li. So this is our list item right here. Now we want to add content to the newly created list element, and we want that content to be the task that the user enters here. So we will change its inner HTML by using li.innerHTML equals, we'll create a set of backticks to use our task test variable dynamically by writing a $, then task text. And let's say we have to create a button which deletes the task as well. So I'll create a button class equals delete. Let's say I'll give it a class of delete, and then I'll say delete, or you can add an emoji of a delete X or cross button right here. For now I'll add delete and then button. So this will be the content of our newly created list item, and after creation of the list item we have to add that list item to our task list. So our parent element is the unordered list which we have selected in the variable called task list. So task list dot append child, and the child we want to append is our li variable right here, which we have created. So after adding our task to our task list, we want to clear the input field for the user to enter another task if the user wants to do so. So for that we'll do task input dot value equals an empty string, which means clearing the input field. So this is it for our add task function, and I have noticed that this C should be capital right here, and this function is now complete. Now we want to make it so that whenever a user clicks on this add task button, this add task function executes, and we will achieve that through the use of event listeners. So we have discussed that in our JavaScript beginner series, and we do that by setting or attaching an event listener to this add task button. So we have selected this button in this variable right here. So add task button dot add event listener, and let's say we should execute this function on click, and then the function to be executed is add task. So by doing this we have attached an event listener to this button right here, which when clicked adds our task from the input field onto our task list. So let's see what happens if we enter let's say take out the trash and click on this button. So we can see that this take out the trash, which is our task, has been added on to our task list. So our function and our event listener is working perfectly. Now if we want to delete this task right here, we would naturally click on the delete button, but we can see that clicking on it does nothing. So this is because we have not created a function that deletes the task, and we have not attached it to the delete button. And in order to make the delete button functional, we'll have to do just that. So this will help us delete the task that we have already completed, and we'll now head on to creating a function which deletes the task. So let's say delete task, and this function will take a parameter which is e, and you can assume this as the event object which we had discussed previously. It contains all the details regarding the event that is triggered, and we will open the function right here, and we will create a condition which reads if event dot target dot class list dot contains a delete class which we had added to our buttons or our delete buttons when we created this right here. So this class delete, if it contains the delete class, it will remove its parent element. So event dot target dot parent element dot remove. So the reason I typed parent element dot remove, when we create the delete button, it is a child element of our list element. So first we create the list element right here, and then we have created a button element inside the list element. So since we want to delete the whole list item itself from our task list, we remove the parent. So when the delete button is clicked, it will remove its parent element, that is the newly created list item. So inside this delete task function, this first line essentially asks if we have clicked on something that has the class delete. So class list dot contains delete asks if we have clicked on something that has the class delete, and if the condition is true, it removes its parent element. So now that we have created the function, let's see this in action. Now in order to see this in action, we have to attach this function to our task list or our unordered list. So to do that, we will have to use the task list dot add event listener on click, and then delete task. So delete task, our function. Now let's see if this works. So I'll use wash the dishes as our example and hit add task. The add task function is working fine. Now let's see if we can delete this task. And as you can see, the task that had been added has been successfully deleted from our task list. So we have already created a basic version of our to-do list app where we can add tasks and delete tasks after they are done. So we have already created a basic version of our to-do list app where we can add tasks to our task list, and after they are done, we can delete them right away with one click on the delete button. So we can take this app to another level by fetching tasks from an external API. Now this is not entirely necessary, but in order to use and demonstrate the fetching mechanism in JavaScript, and in order to incorporate that into our to-do list app, we will be doing just that. So we will create an asynchronous function which is fetch tasks, that will fetch tasks from an API. So try const response equals await, since we have to await the response, then fetch, and then our API. So fetch this, and then in another variable that is const data, we will await a response and then convert it into a JavaScript object, so response.json. And after that, we'll be using something called a for each loop. So since we have stored our response.json, which returns an array in the variable called data, we'll use a for each loop to loop through each item in the array. So data.for each, let's open our parentheses and create a variable called task. Now each item that is present in the array is stored in this task variable. So for each item in the array, we want to execute a certain code. In this case, for every task in the data array, we want to create a new list element and add that list element to our list or unordered list, which is our task list. So for that, we will have to create a list variable like we did in our previous function, that is add task, and then use document dot create element, and our element that we want to create is a list element. So this, and in a similar way as we did before, we want to change its inner HTML and use our backticks to use the value of task dot title, so which stores the title, or which uses the title of each task item that is present in the array that we receive from the API. So task.title, and then we create a button for deleting the task, so button, and let's say its class is delete, so delete, and then it says delete, and then we'll close our button. So we have changed its inner HTML, and now we will append this item, our list item, by using append child to our unordered list, which is our task list. So this, And after writing the code for our try block, we have to write a catch block for any errors that might occur. So catch error, and let's say console.error, an error occurred while fetching tasks, and then let's say we add our error message onto here, so plus error. So we did make a function for fetching tasks from an API and adding them to our task list. Now let's attach that function to our fetch API task button. Now we'll use fetch task button, and use dot add event listener. Let's say we have to trigger that event on click, and then we have to trigger this function, so fetch tasks. And let's not forget to close our function right here. We'll close this, and then we'll see if our code works as intended. So let's say finish the project video and add tasks, so it has been added to our task list, and then delete, so it is being deleted as well. And let's see if our newly created fetch API task or fetch task function works. So let's click on this, and we can observe that our fetch API task button is working fine, which means that our fetch task function is working fine as well. And let's see if we can delete the task that we just fetched from an API, and delete. So we can see that our delete task function that we created previously is working well on this fetch API task button as well. So delete. So in this video, we built a simple yet functional task manager app by using JavaScript. And let's quickly recap what we did. We created a function and added it to our button so that we could add tasks to the list, we can delete tasks from the list, and we can fetch API tasks from an external API and display them on our screen. So if you found this project video helpful, don't forget to like, share, and subscribe for more beginner-friendly JavaScript projects. So let me know in the comments how your task manager app turned out, and we'll catch you in the next video. Thank you.